Welcome, friends, to an important session on what, why, and how by Stats HD. The topic of our discussion or the tutorial is dispersion. We would be studying what is variance and standard deviation. This topic is especially important in terms of calculation as it involves calculations from the mean. So, let's understand what is dispersion. What is dispersion, variance, and standard deviation? In simple English language, dispersion means the scatter around a value. Look at your screen. In the center, you have the mean weight of a class of students. So, the mean weight is 50. I have data of say 30 students. Their weight varies -50 to +50. So someone might be 40 kg. The lowest weight in the class was 40 kg. And the highest weight of the student in the class was 60. And all the 20 students' weights are scattered in this range. So we calculated the mean weight as 50 kg. If you want to understand how to calculate mean or arithmetic mean, do visit my previous tutorials on calculating mean for both grouped and ungrouped data. Now, if you notice on the left hand side, -10 kg is the negative spread or the dispersed values of the weight around the mean weight. So I have -10 kg, which is on the left hand side of the mean weight 50, and on the positive side I have +10 kgs. If you notice the stars, if you see, those stars denote maybe the mean weight or the individual weights of the students. In the center, it would be 50, and towards the extreme right or extreme left, if you see the size of the stars, they might be smaller or greater depending on the left or right side. If you notice, the biggest star on the right hand side maybe might be an outlier. I've put that big star to denote maybe what if a student is 100 kg, he would be an outlier in the class where the mean weight is 50 kgs. So dispersion very simply means the dispersion of the values around a central layer or the mean weight. Now coming to what is variance and what is standard deviation. Variance and standard deviation are statistical measures of dispersion. In very simple words, variance means vary or variance is the average of the squared deviations from the arithmetic mean. How it's calculated, we will see in our next slide. Whereas standard deviation is a calculation derived from the variance itself, actually is the average distance the values fall from the mean. The Greek letter sigma. So we can have 1 sigma on the right or 2 sigma or -1 sigma or -2 sigma on the left hand side. Now, look at this normally distributed curve. This curve was named after Gauss, who had presented this normally distributed curve. Now, what are the important properties is what we will understand. Now, if you see in the center, I have one specific symbol which is mu. I am highlighting it here. It means the population mean is denoted by mu. And if you remember, for a sample data, X bar denotes the sample mean. So around this population mean, we have dispersion or scatter of values. In this case, I have already calculated that the standard deviation is 2 kgs. So one standard deviation would be 52 kg on the right, and -1 standard deviation would be 48 kg on the left. Now, why is this curve very important? If you notice, statistically and mathematically, it has been proven that around the mean 50, 68% of the class would fall between 48 and 52. With confidence, you can say that 68% of our class have weights between 48 and 52. If I increase two standard deviation, that is 2 into 2, that is 4. So it would be 50 plus 4, that is 54. And on the left hand side or the lower side, I would have 46. What is the importance of two standard deviation? We can with certainty say that 95% of our class ranges between 46 kgs and 54 kgs. And if I want more inclusion, I can take three standard deviation, that is 3 into 2, that is 6. So 56 kg on the upper side and 44 kg. With 99.72% accuracy, I can say that the class varies between 44 kg and 56 kg. Whenever we are inferring some conclusions from a sample or a population data, we need to make some conclusion. So here, if you want to make a conclusion on 99% of the class, we would have to calculate three standard deviation. So that is the importance of calculating standard deviation. Now let's move how to calculate what is variance and standard deviation. Before that, why study standard deviation? Normally, standard deviation is one of the best measures of dispersion. If you have studied mean absolute deviation, we take the mean values and we subtract it from the mean. But in that case, we ignore the sign, and that is mathematically incorrect. Whereas in standard deviation or variance, we square the difference. So it is mathematically more correct or a better measure of dispersion. When we want to compare two data sets, we can compare the standard deviation, or we can also calculate coefficient of variation. So that I will come to at the end of this tutorial. Also, because this being a standardized measure, you can with certainty claim that this is the standardized measure. A standardized measure is something like percentage where you can compare two data sets. Now, we will be looking at calculation of both ungrouped and grouped data. I have put up data on the earnings of 6 employees. Their earnings range from say 240 rupees to 270 rupees. So these are the earnings of 6 employees. We want to understand what will be their mean and what is the dispersion. Now, the simple method would be to calculate the total of all of these and then divide it by 6 to calculate the mean. But in this case, we will use the assume mean method. In an assume mean method, what we do is we will assume a mean to be 250. Now we need a deviation. D stands for deviation. So I will show you how do you calculate. So you take the first observation x1, that is 240. 240 minus 250, as we subtract a higher number from a smaller number, there would be a change in sign. So the answer would be minus 10. I take the same value and square it up. So this would say become 100. For the second observation, 260 minus 250, it would be plus 10 and square would be 100. 250 minus 250 is 0, so the square would be 0. 245 minus 250 is certainly minus 5. Please note, when you subtract a bigger number from the smaller number, the answer would be a smaller number with a minus sign. So here 245, if you see the formula here, it is x minus a and not a minus x. So please be mindful of that. So minus 5 square should be 25. Now we need to complete the entire table, and to calculate standard deviation, we have a formula. As I told you, sigma stands for standard deviation. So the formula mentioned is square root of summation d square upon n, that is the number of observations, minus summation d upon n bracket the whole square. I have already calculated the values for you for the table. Let's look at them. So this I will recap. We have deviation which is x minus a, 240 minus 250 is minus 10 and the square is 100. If you're wondering what's a is my assumed mean which I have assumed it to be 250. If you're using the assume mean method, you can also take 245, 255 or 260. Only these values would change. Now coming to the calculation. So my calculation sigma equals to, let's calculate sigma d square upon n minus sigma d upon n the whole square. This actually denotes variance and it is denoted by sigma square. So let's calculate. So summation d square is 650 divided by 6, that is the number of observations. Summation d we calculated was 20 and the number of observations are 6. Remember, this comes in bracket the whole square. 650 divided by 6 would be 108.33 minus, if I divide 20 by 6, my answer should be 3.33. So keep it in bracket and square it up. So my final answer would be 108.33 minus 9.3.33 square should add up to 11.08. And finally, I would get 97.25. Please note this is not standard deviation but variance. Assuming my mean was 250, I have got variance as 97.25. This means if the mean was say rupees, this is denoted in rupees square. So it makes very little sense. Therefore, to get it back to rupees, we square it up and when we square the variance, that is sigma square, we get sigma, and the square root of 97.25 comes to 9.86. In simple words, let me draw the normally distributed curve. If these are my observations and say this is my mean, say 250, I have one standard deviation, that is 250 plus 9.86, that is 259.86. And on the lower side, it would be 250 minus 9.86. So approximately it would be say 240.05. Okay, just a second. So I can confidently say that 60%, 68% of the weights or the wages of the employees lie between 240 and 259. So this was the calculation for ungrouped data. Coming to the group data, if you remember, group data is denoted by class intervals. So assuming, look at the data given. The profit for the firms are given between 0 to 10 lakhs, 10 to 20 lakhs, 20 to 30 lakhs, 30 to 40 lakhs, 40 to 50 lakhs, 50 to 60 lakhs. In a class interval, if I take this class interval, this denotes the lower limit and this denotes the upper limit. The frequency shows how many companies have profits between 0 to 8. 12 companies have profits between 10 to 20. So on. So this denotes the frequency. Now, to calculate the variance and standard deviation, we need to calculate the deviation. To calculate the deviation, we have to convert the class data into discrete data. So the best way is to take the mid value of the profit or the class interval. So between 10 to 20, the mid value is 15. Between 0 to 10, it is 5. Now I can take the deviations from this. So assuming I take 25 as my assumed mean, so I circle 25. So the formula for deviation is mid value minus assumed mean divided by h. H denotes the class interval which is 10 in this case. So between 10 to 20, the class interval is 10. Between 20 to 30, the class interval is 10. So let's do the calculation for M1. M1 is 5. 5 minus 25 is minus 20. So I write it here, minus 20, and divided by h, that is 10. So it should add up to minus 2. In case of M2, it should be say 15 minus 25, that is minus 10, divided by 10, it would be minus 1. 25 minus 25 is 0, so in this case it would be 0. 35 minus 25 is 10 divided by 10, which is again 1. My next step would be FD. So I take F, that is 8, multiplied by D minus 2. So my answer should be minus 16. 12 into minus 1 is minus 12. I also go ahead and take the D square. So minus 2 square should be 4. Minus 1 should be 1, 0. So if I do F into D square, that is 8 into 4 is 32. 12 into 1 is 12. I have completed the table for your reference in the next slide. So if you notice, I will recap here. To calculate the deviations, first I will take the mid value of the class interval. So between 10 to 20, the mid value is 15. Between 20 to 30, the mid value is 25. So step 1, find the mid values. Step 2 is find the deviations. The formula for deviation is m1 minus assumed mean divided by h. So I have assumed the mean to be 25. You can take the assumed mean to be 35, 15. Normally, I suggest take the middle value. So 5 minus 25 is minus 20 divided by h, which is 10. So if you notice here, 5 minus 25 upon 10 is minus 2. I take a square of that, minus 2 square is 4. Now FD is your frequency multiplied by D. 8 into minus 2 is minus 16. 8 into 4 is 32. Let's do it for the fourth observation. So we have D as 1. So 30 into 1 is 30, and 1 square is again 1. So 30 into 1 FD square is 30. So in a sense, I have calculated FD and FD square. The sum of FD is 72 and the summation of FD square is 244. The formula for group data is similar, which is sigma equal to summation FD square upon n minus summation FD the whole square into h. This is an additional parameter which you shouldn't forget, because while dividing we divided by h. So in the final answer we multiplied by h. So let's complete the calculation. So I write sigma equal to summation, so I put the square root, summation FD square is 244 divided by n. Always in the frequency table, n stands for the summation of frequency, which is 100, minus summation FD. Summation FD was 72 divided again by 100, the whole square, and finally we write multiplied by h or by 10. So let's complete the calculation. 244 upon 100 should be 2.44, minus 72 upon 100 is 0.72, the whole square. Let me complete the square root, into 10. 2.44 and 0.72 square is 0.5184. So 0.5184 into 10. 2.44 minus 0.5184 adds up to square root of 1.92 into 100 into 10, sorry. And when I take the square root of 1.92, it comes to 1.39 multiplied by 10. So therefore, my standard deviation is 13.9. I will recap how to calculate standard deviation for group data. So when you have group data as given on the left hand side, profit and frequency, we take the mid values. Then we find the deviation, that is m minus a upon h. In this case, I've taken the assumed mean as 25. So 5 minus 25 is minus 20 divided by h, that is 10. H stands for the class interval, that is minus 2. Similarly, you can find d, then fd, then take the d square and then find fd square, and your formula is square root of summation fd square upon n minus summation fd upon n the whole square, and then you multiply by h. Please remember, when you multiply by h, you would not take it while calculating the square root, but you would only multiply after you complete the square root. So this was the standard deviation. So in essence, if my mean was say 25, my standard deviation on the right would be 13.9. So 25 plus 13, and on the left it would be say 25 minus 13. Now in the next slide, we have another formula which is coefficient of variation, which is basically we are converting the standard deviation into something which is called as COV, which is comes in terms of percentage. So assuming your standard deviation was say 10 and the mean was say 25, you multiply it with 100. So your value should come to 0.4 into 100, that is 40%. So for A, my coefficient of variation is 40%, and for B, my coefficient of variation is 60%. If their mean is 25 and you're comparing the coefficient of variation, we can clearly say that B is more dispersed or more varied. So assuming 25% was your mean average return from two stocks who give you similar returns, but stock A gives you closer returns, which is not deviating too much, whereas stock B, which has mean average returns of 25%, is widely fluctuating minus 60% to plus 60%. So I would prefer to go for stock A. So this completes the tutorial on dispersion. We have discussed variance, standard deviation, and coefficient of variation. If you have liked my tutorial, please give a thumbs up and also do subscribe to my channel. Thank you.